All right, my most humble apologies. My entire computer, like, essentially just decided to explode on me on that previous video. So we could start right. We could start back up where we left off. All right. So we left off here, where we were picking values for our next or for our intervals. All right. So if we take a look here, we have -2. We have gotten that first one. So let's go with -0.5 on our second interval. And then from 1/3 to 2, let's go with 1. And then from 2 to infinity, let's go with 3. Okay? So now we need to figure out what those function values are. Now we need to figure out what those function values are. So let's take a look over at our calculator. All right. So if we turn our calculator on, in y equals, we put our function that we're looking at. So this guy right here, we want to put in our calculator right here. So once we do that, we want to take a look at the table. We want to take a look at the table. So we're looking for the function value where x is equal to -2. Let's go ahead and hit the up arrow to get to -2. So we get that our y value is 28. Y value is 28. So let's go ahead and fill that in. 28. And it's not just 28, right? It's -28. Good, wonderful. -28. Excellent. And then there's -1, 0, just like we anticipated it being. Excuse me, I had a hiccup there. So then our next number is zero point 0.5, but we also have 1 and 3. So let's take a look at those. X equals 1, y equals -4, and then at x equals 3, y equals 32. So this is -4 and then 32. So let's go back up to here. And we are going to, whoopsie daisies. We are going to take a look and we're going to say, all right, we'll start at 0, but I want to jump by 0.5. I want to jump by 0.5. So at x equals -0.5, y is going to be 3.125. So we have 3.125 for our y. Okay? So we have a point on each of these intervals. Great, wonderful. We're the best. Go we. All right, so let's take a look at step 5. All right, so there's our table again. But if we don't have f of 0, we want to find it. All right, so we want to fill this in and put f of 0 there because we didn't happen to pick it in our list. So when we plug in 0, well, 3 times 0 is going to be 0. 4 times 0 is going to be 0. -5 times 0 is going to be 0. So all three of those first few terms are going to be 0, plus 2 is going to be 2. Okay. Also, we could find it in our table if we wanted to do that. So, see, there it is, 0, 2. We are the best, 0, 2. Okay. So let's head back into our whoopsie. There we go. Okay, so we have 0, 2. So now, step 6, we need to find additional points to help determine the shape of the graph. I'll leave that up to you, but I'm pretty happy with this set of points, with this set of points. If you want to pick more, again, feel free to pick a bunch on those intervals. Okay. So with those points that we are happy with, let's plot the points and actually make the graph. All right. So we have -1, 0, -1, 0. So then we have, let's see, -1, 0. We have this point right here. Then we have 1/3, 0, which is about that right there. And then 2, 0, we have that point. -2, 28, so that's going to be way up here. Or excuse me, -2, -28, which is going to be way, way, way down here. Oops. There we go. -2, 28, -28 is going to be way down there. Then we have -0.5. 3.125, so just a little bit above 3. Good. And then 1 goes to -4. There we go. Found it. And then 3 goes to 32, which is way up here. And then 0 is at 2. So we have all of these points from that table. So now, when we connect our dots, coming down, then back up, like that. And hopefully you actually like hit your points that you're trying to hit. We'll say I did that the first time. That looks a little bit better. Okay, so we have that point, we have that graph. So now let's take a look at our calculator and see if that is indeed what it looks like. So then we have that guy typed into Y1. So then we're going to go ahead and graph it and see what the picture looks like. And would you look at that? That guy looks a whole lot like our graph that we made. Okay, so that is the first one. Let's work through another one. Let's work through another one. All right, there we go. Let's work through another one. All right, step 1. Use leading term test to determine the graph's end behavior. All right, I'm going to leave that one to you. So go ahead and knock it out. Ready, set, pause. All right, hopefully you found out that it was up and up because our leading coefficient is positive and the exponent, the degree of our function, is even. So even degree and positive means that our end behavior is going to be up and up. All right, so let's take a look at step 2. Can you factor it? Can you factor it? Spoiler alert, no you can't. Okay, so we want to use the rational roots theorem to find all those possible rational roots. All right, I'm going to give you a second to pause so you can do this part on your own. Ready, set, pause. So by using the rational roots theorem, we find that our possible rational roots are going to be plus or minus 1 and positive or negative 3. Positive or negative 1 and positive or negative 3. We're not going to have any fractions here. So that's a thing. We like, I get the vibe that you guys appreciate not having fractions. Okay, I get the vibe that you appreciate not having fractions. All right, so let's take a move over to step 2 and keep going with step 2. So now we need to use Descartes' rule of signs to figure out what's going on, figure out what our possible solution scenarios are. Then once we have those, we want to use synthetic division to find those rational number zeros. And then again, each zero you find, step down your degree until you get to something factorable or a quadratic. All right? So I'm going to give you a second to use Descartes' rule of signs and figure out what your solution areas are going to be like. Ready, set, go. So Descartes' rule of signs shows us that we can have either 1 positive and 3 negative roots with no imaginary solutions, or we could have 1 positive root, 1 negative root, and 2 imaginary solutions. Those are our 2 options. Those are the 2 things that we can potentially have as our solution spaces. All right. So it doesn't give us a whole bunch to start guessing with, but use that information and maybe start guessing with positive solutions. So start with positive 1, start with positive 3. See if either of those are solutions. I'll give you a couple minutes to I'll give you a second to pause that. Once you're done pausing and figuring out what your solutions are, I'll come back and talk you through what I did. All right, so I finished this up and found that I started with 3 and doing synthetic division because I wanted to start with a positive number because I knew there had to be 1 positive number. So I was hoping that that thing would be a rational number. It won't always be, but in this case it is. So I wanted 1 positive number, so I started with 3, hoping it would be 3. And then when I did synthetic division with 3, I ended up with a remainder that wasn't 0. So 3 was not a root, not a solution. So then I moved on to 1. When I plugged 1 in, when I did synthetic division with 1, I ended up with 0 for a remainder, which means that 1 was the solution. So 1 is the first solution I found. And then remember, whenever you do this, you always get a polynomial as your answer. So x cubed plus 5x squared plus 7x plus 3 is what we get from 1, 5, 7, and 3. Because we started with a 4th degree, we stepped down by 1 degree, so we start with a 3rd degree here. And then we can continue doing synthetic division with those numbers. This guy doesn't factor nicely, so I wanted to keep synthetically dividing him. So then I started with 1 again, because I wanted to check to see if 1 had a multiplicity. Doing that, I found that 1 didn't show up again, which made me sad. I could have skipped it because if I have only one positive solution, one couldn't show up twice. So I actually kind of wasted my time a little bit here. So then I moved on to -1 in hopes that I would find either my one other negative solution or my 3 other negative solutions. So I used -1. And doing synthetic division, I got 0 again. So that means that -1 was a factor, was a solution of this guy. So I got the function x squared plus 4x plus 3. Now, hopefully you notice from there that you can then factor x squared plus 4x plus 3 to x plus 1 times x plus 3. And then set both of those equal to 0 and solve for x to get your remaining terms. But in case you didn't didn't recognize that, that's okay. Just use the 1, 4, and 3 that you get here and use synthetic division again. I checked -1 again just to make sure just to see if we had any multiplicity. And would you look at that? We did. Okay, we did. So I had a 0 and -1 worked again. So I have -1 and -1, which we can then rewrite to be just -1 with a multiplicity of 2. So again, we have x plus 3. We could just set that thing equal to 0, solve for x. But in case you didn't recognize that, that's fine. Check -1 again. Bring the 1 down. And I got not a 0 for a remainder. So -1 didn't have a multiplicity of 3. So then I checked -3, brought the 1 down, multiplied it by -3, added, got a remainder of 0. So now we're out of things to use synthetic division with. And also we needed 4 solutions. We found our 4 solutions, so we're done. All right. So the situation we had was we have x equals 1, -1 with a multiplicity of 2, and then -3. Okay, so we have 3 solutions. We have 3 different solutions, but one of them happens multiple times, which is okay. It's a thing that happens. Okay, so of our Descartes rule of signs options, we ended up with this first option again. So 1 positive solution, 1, and then 3 negative solutions, -1, -1, and -3. So we have those two that scenario happening. Okay, so from here we want to move on to listing those and having the coordinates of our x-intercepts, which are 1, 0, -1, 0, and -3, 0. So those are our coordinates of our x-intercepts. So now we want to make some intervals with those values. Okay, so I'm going to give you a second to make those intervals. So go ahead and make those. Pause the video and make your intervals. Ready, set, go. So hopefully you paused and found that the intervals that you want to work on are -∞ to -3, -3 to -1, -1 to -1 or to +1, and then 1 to infinity. Okay. So now we want to select some additional function values for those intervals. So select those x's, find out what their y components are, and figure out your additional points. You need 4 additional points, so I will see you on the other side of your selection and identification of what those y values are. Ready, set, pause. All right, hopefully you found some similar points to mine. If you didn't find these exact points, but they're still in the interval, that's absolutely fine. Just make sure that they are on those intervals and you get meaningful points out of them. So if you then take a look at your table, and your calculator, hopefully you can find similar values. Okay, so hopefully you can find similar values that in our table. Okay, so then once we have that, we can then move on to step 5. We want to find f of 0, which gives us the y-intercept if we haven't already. Luckily for us, we already have it. There's 0 right there. See it? Right there. Okay? So there's our 0. F of 0. So we don't need to find anything else. We can skip step 5. And then step 6, find additional points to help determine the shape of the graph. If you would like additional points, please select them and use them. I'm going to stick with the points that we have. So now I want you to plot the points that we have and make the pretty picture. I'm going to pause, let you do that, and then come back and show you what it should look like. Ready, set, pause. pause. All right, so that's the best approximation I can do of that picture. So of that graph, notice how at x equals -1, it comes down, comes up, touches the graph, turns around, and then comes back up. We want it to touch and turn at 1 because that -1 had a multiplicity of 2. So that is what we want to happen there. We don't want it to actually cross the graph. So if we then take a look at our calculator, and then we hit the old graph key. Let's see if our picture is going to be anything similar to what we have there. Not too bad an approximation. Not too bad an approximation. Only thing, it looks like it gets down, like there's 3. So if you had connected those dots exactly, you're not getting these sort of lower points here. You're not getting these sort of lower points right here. So there's 3, right? So if we make a horizontal line, we can see that the graph actually kind of goes below the 3 value. Not the end of the world. It's close enough. We're doing okay. Okay? Because if we go from there to there, those graphs are remarkably similar. Okay? So I hope this was helpful. I hope this gives you an idea of how to do this. I could literally show you examples all the time. Like I could continue to show you examples of this, but until you actually just try to do it on your own, it's not going to, there's not enough time for me to show you enough examples to do the things that you're supposed to do. All right? So to recap, remember this process. Whoopsie daisies. This process right here. This is going to be what's important. If you can do these, you're going to be in business. You're going to be able to graph this stuff. All right? So go ahead and get after your homework. You will have a quiz tomorrow, so please be prepared for that. It's going to be over everything we've done this week, over all of the stuff that we've done since the last quiz. So everything that we've done since before Thanksgiving, the 2 days before Thanksgiving. So look at those homeworks, review, and become prepared for your quiz tomorrow, okay? Sounds great to me. Hopefully it sounds acceptable to you. If it doesn't, it's happening anyway, so you might as well accept it. I will see you on Monday. Good luck. You're awesome. Many, many hearts going your direction. Okay, bye, guys. Have a great weekend. Talk to you later.